There's something slightly interesting, I suppose. This is a little lamp. Actually, it's not interesting, it's a lamp. Never mind. Okay, I made it interesting again. This is a lamp with a shock mount. That's got to be interesting. Come on. Don't kid yourself, this is interesting. Okay, anyway, this is a signal lamp used in old, high-end, possibly military-ish indicator switches. Like just on-off switches and momentary switches that had lights in them. And this is an incandescent lamp, as you can see it. This one's burnt out. This is for a radio exciter in my shortwave radio transmitter that had one lamp that was burned out, one that was okay. Obviously, the one that was on all the time is the power indicator, and that one's burned out. So I just pulled that out and swapped it with one that's not as necessary to use. I might be able to get a couple of more of these. I'll have a look on eBay and see if you can just buy these, or if there's some. It says Taunuslight, something like that. And it's a 24-volt, 20 milliamp lamp. I'm not sure if this is AC or DC. It's probably. I mean, it wouldn't matter for a lamp, but in this specific thing I've pulled this from, it's got to be DC because there's no 24-volt AC rail. At least normally there wouldn't be. The only reason you'd have one is, in that case, is to power a lamp, and that's pointless. But it got me thinking. Could I just put in a LED or something? That'd be kind of fun. It doesn't need to be very bright. We have 20 milliamps to play with. Let's see what we can do. I'll try to get a LED and see what that looks like. Wow. That's a red one. Got a couple of different colors. They're all the same size, obviously. These are just 5mm LEDs. And it looks like they're pretty close to matching. And remember, the way they're mounted, these things, there's quite a bit of clearance around the edge of the bulb here. It's this metallized part here is obviously the contacts, you can see, and there's a little catch here where the contacts actually grab. So you do need some rigidity in this section, but the hole that this thing goes into, once it's out of the metal part, is actually about that wide. So, and if you look at the size of the LED and stuff flying up, in terms of length and stuff, it's almost like it isn't a coincidence. But yeah, should be plenty of room in there to put in a series resistor or two, assuming I can get the lamp out without damaging the socket. Then I could potentially just put in LEDs and have everlasting indicator lamps. Okay, we're about halfway there. I broke off the little pipette here at the back, and it's just hanging in by the wires. Looks like they're just soldered on there. Yeah, that's looking pretty good. I'll just get the old snips out here. I'm doing this behind the camera, so it's pretty hard to see what I'm doing. I don't want to bend the socket too much, because if I do that, then it'll be difficult to get it back together. But what if I just wiggle it a bit, jerk it around? One's loose, second's loose. Okay, that's the actual lamp out. Put those to one side. And one issue here, obviously, is the fact that it's not polarized, the socket. So, two choices. We can either simply, we can either put in a bridge rectifier and run the diode through that. That way it'll work regardless of orientation. Or we can simply include a series diode. Say that, you know, if you plug it in and it doesn't light up, plug it in the other way. And I'm leaning towards that because I'm just going to use this myself. I know exactly what it's going into, and once it goes into the switch, it's never coming out until the diode burns out or something. I think we're going to go ahead and do that. Okay, I'll just pull up my cell phone telephone here and calculate the required resistor for a green LED, which is what I need, a standard green LED. It's about 2.2 volt forward voltage, and we have a 24 volt thing. We need about 2K for 10 milliamp, which is pretty high. So 2.2K. I think I'll use two 1Ks just to get some balance in the mechanics, and also to just increase the power dissipation. So I'll get that set up. Sure hope I have enough resistors. It's gonna hurt. Anyway, it's 2.2K nominal, but I want to have some tolerance on that, so I'm going to go ahead and use one that's 1K. That's that one. And then I'll use one that's 1.8 for a total of 2.8K. That slightly derates the current. We don't need much intensity out of these. You just have to be able to see that it's lit. That's all. There we go. I'll have to make up some kind of soldering jig. I'm going to use a green, as I said. And let's have a look at the mechanics here. I'll be alright. And I'm going to throw away that lamp. Yeah. Okay, I've got a LED mounted in the universal vise here. I'll do is I'll pop off that leg, having previously established that this is the positive, or the anode. And what I'll do now is I'll just use these pliers here and bend that leg. I've already tinned this, and now I'm gonna just add a little melt surface mount diode in series. Now this is my first time trying to solder using the camera, so we'll have to see how this goes. There we go. That's not too bad. Yeah, that's now the positive. Next step is to try to verify or work out the lengths needed for the resistor legs. Lamp socket there, you can hold it like that. I've added the series diode there. That will slightly affect the drop voltage, but at 24 volts in, that difference will be negligible. There we go, that's the first one. Socket's still in one piece. Just flip it around. And we'll try to do the other one. Ooh. Okay. I'll to get this up to my eyes to inspect this. Well, it's kind of warm, but it looks okay. And what if we just put this in sort of like that? That way I can bend one lead back on one resistor to attach to the diode. Let me work on this. Okay, I think I've got the solution now. So I'm going to that joint first. That's pretty good. Let's just trim the excess here. Ah, I got a little joint there, and a little joint there, and a little diode. Series resistors. That's lighting up. Killing the overhead lights should make it easier to see, but yeah, that's a little less than 20 volts. Might be a little dull, I suppose. But shorting out one of the 1K resistor should take care of that if I needed to. Okay, since the last cut, I decided to replace the green one with another super bright. I went ahead and I did this orange one, as a super bright yellow LED. I didn't have an orange one around, but I think it came out pretty well considering. There's a front plate that's supposed to go on over this to cover it up. It sits around here, so it's just the tip of the switch that sticks out. And I'm going to include another switch in here that's nominally this one, but I might be able to get another of this type with the same sort of lights, which would be ideal. So I'll just power this thing up so you can see it. There we go. It's a bit of fan noise. Fan always runs. And as you can see, that's the green. It became pretty bright. Green LEDs are pretty damn bright. And that's running at around 10 milliamps. With the old one, it was much less visible, and I had to actually bypass the 1Ks, just use 1.8K as a series resistor around about 15 milliamps. It wasn't even half as bright as this one. So with the point of the orange one there is to let you know that the local oscillator has been disabled because of a change in frequency. So I'll show you more of this. Basically, if I change the digit on this thing, that turned on, and you just press that, it goes off, and there's a little LEDX ladder, no motor thing in there that turns around and stuff if there's a change of band. It's all part of a larger system. While I've got this thing fired up, I'll just get a shot of a Nixie Tube. This is a slightly special type, so you'll see. Okay, that's the Nixie, and what's special about this is that we're actually looking at the top of the tube right now. There's 6 Nixie digits that in total give you kilohertz adjustment up to 29.999 megahertz, 0.9. So it's 1 decimal point for 100 hertz tuning resolution. I can just manually rotate that switch there. You can actually see the effect, and that light you're seeing up there at the top left is actually the synthesizer unlock indicator. That goes on in particular when you change between 9 and 0, and that's because I'm looking at the 1 megahertz range oscillator right now.